Wi-Fi deck, ITP guest, ITP Wi-Fi. हाँ, पासवर्ड नहीं तो ओपन ओपन ओपन. So hello everyone, good evening. So I am Baban and I will present you some questions which are mainly from previous year's assignment, and it will help you to solve some of your question in this assignment also. So I'll just wait if 1 or 2 minutes before starting. So this is the first question. We have 4 options and we actually multiple of them can be correct, but in this case we are told that we have to pick only one. So whatever the answer is, which one is like most relevant, we have to choose that one. So the question is, which of the following is a major advantage of decision tree over other techniques, like uh, there are many other, like SB, we have tried earlier in the previous lectures. So uh, the thing is like, why should we use decision trees? There are 4 options. One is that there is theoretical guarantee of performance. Second one is that it has higher performance, like accuracy will be higher or things like that. Third option is that interpretability of classifier. So that means whatever we are predicting, we can give a reason that because of this is higher than this, or this is not this, that is why we are predicting it like that. And finally, the last option is the it is very powerful to represent complex function. So these are the four options, and you have to pick only one. Even though like it may seem that multiple are correct, but like you are specifically told to pick only one. Okay, so one answer I got C. Anyone would like to answer it? Yeah, C. Yes, the answer is actually correct. So even though it can actually represent a complex function, and but the main reason we use it is because it is like more interpretable. Whenever we are building a decision tree, we can see that the if it is greater than this, then we are saying yes. If it is lower than this, then again we are creating multiple branches, and then again we are checking another condition. If it is true, then we are classifying this, or otherwise we are classifying that. So that makes the whole thing, the classification system interpretable, that yeah, because of this it is saying it is no. Okay, so we can get the intuition behind the decision made by the classifier. Okay, so this is the correct answer. So let's go to the next question. Increasing the pruning strength of a decision tree by reducing maximum depth. So
Sir,
basically,
last question.
yeah,
Answer C.
yeah, answer is C.
Last question.
Yes, last question, answer is C.
Okay, sir. Thank you.
Yeah. So this question, so you are pruning a tree, and suppose pruning trend is high, like you are increasing the pruning, okay, and you are reducing the maximum depth. So suppose initially it is maybe 20 was the depth, you are reducing it maybe 11, 12 or something like that. So what will happen in this scenario? So first option is it will result in improved validation accuracy. So basically it is not saying anything about training accuracy. It can increase, it can decrease, whatever, but whatever happens in training accuracy, it will improve validation accuracy. So this is the first option. Second one is that it will lead to more of overfitting. So overfitting means training accuracy will be high, but validation accuracy will be low, right? So second option is that. Third option is that it will lead to underfitting if set too aggressively. That means if we are pruning the tree, if we are limiting the depth, so what will happen is that it will not be able to get like generalize on the data. It will uh, not perform good even on the training set, let alone the validation set. So third option is that. Fourth option is that it will have no impact. So whatever, even if we are using the original tree, or if we are using pruning, so basically it is meaning to say that the like reason we are using pruning is that it does not affect the performance of the tree. So that is why it might be helpful to use the pruning. So is it correct? So that is the option 4. And option 5 is will eliminate the need for validation data. So if we use the pruning, then we don't even need to perform validation. So these are the 5 options. Only one of them is correct. So which one is it?
Third one might lead to underfitting.
Okay. Okay. D. So D and C. Okay, let's see. What is in D? D is will have no impact on tree's performance. Okay. Then any more answers? A is what? It will always result in improved validation accuracy. Okay, so we got three choices as of now. Okay, so let's go one by one. Which one is correct or incorrect? So first option is that it will always result in improved validation accuracy. So suppose you have a tree and you are removing some of the nodes, okay, and some of the suppose it was at first it was 20 depth, now it is 10 suppose. So you are basically reducing the depth. So the thing is that if that happens, uh, the model is getting more less complex than the previous one. So initially it was larger tree, it had more nodes, but now it is less number of nodes, okay, and depth is also less. So it is much less complex. It is much simple than the full tree, okay. And if that happens, we cannot be sure that it will actually decrease, like it will improve the validation accuracy, because yeah, in case of overfitting it can happen that suppose with a large tree it was overfitting, okay, and if we are cutting that, so it can happen that now we are fitting it correctly, not overfitting, not underfitting. So it can happen that in that case it can improve the accuracy, validation accuracy, but it is not really guaranteed. So it can happen that it was fitting correctly on the first try, but if we are removing some part of the tree, it will have the much worse performance, okay. So this thing is not guaranteed. So this is not really correct answer. Then let's go to the option B. It will lead to more overfitting. So this is clearly not correct. Suppose we have a large tree and we have a small tree, like smaller version of the tree. So if the larger tree is not overfitting, okay, so definitely the smaller tree will not, because it is much less complex than the larger one. So it will after pruning it will definitely not overfit. So B is not correct. Third one, it might lead to underfitting if set too aggressively. So what it is basically saying is that you have a tree, and if you cut aggressively, suppose from 20 nodes, like 20 depth, to suppose only you are giving 5 depth or 7, 10 depth, okay. So if you do it aggressively, there is a chance that it will be underfitting. So this is actually correct, because maybe in the original tree it was fitting at appropriate level, but when you are making it smaller, it is getting less complex, and because of that it might not be able to capture the properties of the data, right. So that is what we call underfitting. So in underfitting, what happens is that we get both training accuracy as well as testing or validation accuracy, we get very poor. Then it is saying that it will have no impact on the tree's performance, but that is definitely not correct, because I am showing that tree kind of thing. So one is large, one is small, one is more complex, one is less complex. More one is more tend to overfit, and less one is actually more chances of underfitting. So definitely there is a difference in performance, okay. So it is not correct that it will not have any impact on the tree's performance. And fifth option is that will eliminate the need for validation data. So whatever model we are training, testing, or whatever, we need to kind of use validation to understand that if it is fitting properly, if it is only fitting on the training data, if it is not fitting at all, things like that. So it is not really correct that if we just make it smaller, that there is no need of validation data. So another thing is that even though model is simpler, it doesn't mean it cannot overfit. In the simple model also, the chances of overfitting is much lower compared to the higher model, like larger model. but lower model like smaller models can also work it. So that option is also not correct. So only correct option here is option 3 C. So if the maximum depth is reduced too much, then the model might become very simple. So if the model is very simple, it will not be able to capture the patterns of the data, whatever whatever we are giving, whatever features are there and whatever the output is, it will not be able to find the mapping between this. So it will not give a good performance on the training set as well as the validation set. So this is the answer for the second question. So if you have any doubt, you can ask at any time. Then I'll move on to the next question. So I hope everything is feasible. Yeah. Okay, let's move on to the next question. And then after like a few MCQs, we'll get to some numericals also, and then again we'll get to MCQs. So we have two statements. One is decision trees are linear non-parametric models, and this is the statement 1. And statement 2 is that so decision tree may be used to explain complex function learned by neural network. So basically what we are saying is that we have a neural network and which can be complex, which has learned a complex function, a mapping between suppose input and output, and we can use a decision tree to explain that, kind of like yes node kind of decision, that because of it is greater than this, it is happening like this kind of thing. So statement 2 is that, and statement 1 is that decision trees are linear and non-parametric model. So is statement 1 correct? Is statement 2 is correct? Which one is it? Both are correct or both are false, whatever. Okay, so one answer is C, B, A, C. Okay, let me check the answer. So C is statement is false, first one is false and second one is true, and another option is that B and A. Okay, so we got two C's, one A and one B. Okay, so first one is false and second one is true, so this is the C. And statement A is that both are true, and state B is first one is true, second is false. Okay, so basically what happens is that let's go statement by statement. Okay, at first the first statement, decision trees are non-parametric models. So this is not really correct, because decision because in the decision tree, whatever we can do is that we can map a very complex function. We can perform a complex separation. So we can take non-linear decisions in the decision tree, not in the in the simple perceptron. We cannot classify if there are non-linear classification boundary. But in this case, in decision tree, we have multiple branches and we can have multiple decisions at each of the branch, right? And each of the branches, at every point wherever we are taking decision, it might be linear. But if we take look at the whole picture, we are basically dealing with non-linear systems. Okay, so what happens is that decision trees make predictions by splitting the data, which I told, and features at each decision node, and these splits can be based on nonlinear conditions. Okay, so this can be based on nonlinear conditions. Okay, so you can see here a decision node might split the data based on whether specific feature is greater than, less than or equal to a certain threshold, right? So this kind of thing, it is not like we are just dividing a line between those, right? It can be like equal to, less than, greater than, and it can be like this condition. It can be a nested condition, like if this variable is greater than, less than or equal to this, then within that condition it can be like in the node below, it can be like if it is less than, greater than or equal to this. So these kind of things we can do via like decision trees. So decision tree is not really a linear model. Okay, so this statement is false. Then let's go to the statement 2. So decision tree may be used to explain complex function by a neural network. So here this actually is true. So decision tree can be used to interpret the model. So basically, suppose the model is giving approximating a complex function. By that I mean that it is transforming a input. It is mapping an input to the output. So you have a neural network. You are giving some input, and it is giving an output, and that process. So from mapping from input to output, if this is the input, that would be the output. So that mapping, we are calling it as a complex function, and it is learned by the neural network. So what we can do is that if we recursively perform partitioning means like doing the decisions in the decision tree. So it can provide an information that why the model is saying that this one is this class, this one is this class, like that. So based on the condition, like if this is less than, this is greater than this, so based on that we can explain that why the neural network is making a decision. Suppose like consider an example. We have trained a neural network where we have, let's say, a mark of the student in the previous semester, and maybe how many hours the student is studying. Okay, and suppose one person studying maybe let's say 8 hours per day. Okay, but he got very low marks. Maybe suppose he got 40 marks in the previous examination. Okay, so the model is saying that the person will fail. So it is kind of strange that even though he is reading so much, he is failing. His model is showing that he will fail. But then like we can, if we try to build a decision tree that based on the predictions, then we can say that yeah, because that person was getting very less marks in the previous semester, so that is why the model is saying it is he is going to fail. Because you know, in the exams you also need to be, concepts should be very clear from the previous semester, because you know there are prerequisites, and also if you are getting lower marks in the previous semester, it can indicate that you are a slow learner. So even though you are studying much this time, you can still have a difficulty in understanding whatever you are learning. So that decision we can make via decision tree. So but the thing is that if the neural network is very large, so in that case it will be very difficult to make decision, like to understand why this is happening. But theoretically it is possible, right? So suppose you have a very large model. So you can, there will be multiple points that there can be multiple reasons for saying fail, or multiple reasons for saying that he will pass, and it will be very difficult to kind of comprehend that if there are parameters are very large, model is too large. But technically it can be decision can be framed as a kind of as a decision tree, that why it is taking this decision or that decision. So the answer is statement 1 is false, but statement 2 is true. This one is false, but this one it can be done. Okay. So I'll go to the calculation now. So this is from the previous year question. So I think you know how to calculate entropy. It is actually taught in the lectures by Balaraman sir. So can you try to calculate it? I'll just wait for a few minutes, maybe let's wait for much time actually, because this is a calculation. So let's wait for 5 minutes or 7 minutes, and you try to solve this on your own, and then I'll show how to solve it.
Could you please show the question?
Yeah, I'm showing the question. I guess somebody had a question like, is it parametric about decision trees? So it is not really parametric model. It is non-parametric because we don't need any predefined set of configurations to before we start the training. Okay, like it is not like the shape or anything is fixed. Okay, so okay, so if you are unable to solve this question, you can use this formula. So this is the formula of entropy. So in this case, this is the kind of label. Okay, so you have to find entropy based on like this column. In this data, we have age of a child, and if the child is vaccinated, and then we have like tumor size of the child and where the tumor appeared, and then we are trying to find that if that tumor is like dangerous. 1 means dangerous and 0 means it is not dangerous. Okay, so you have to find entropy of the label here, dangerous or not. If you try this, the I actually represents the two classes here, like 0 class and 1 class. Okay, so the calculation is really simple to do. If you can, you should try it yourself, because this kind of things might come in the like in the assignment. Obviously there is, but even in the exam also, or this kind of questions might come.
So first we calculate entropy on the parameter age, right? For age is equal to 5, plus age is equal to 6, plus age is equal to 7, plus 8 plus 9.
Oh no, I'm in this question. I'm just saying for the find entropy based on this one only, alignment. Just ignore all these columns. We'll go there. Okay. For now, just do it on this one, this row, this column.
No, but malignant is the output, right?
Yes, yes,
Other four are the inputs.
yeah.
So then we have to calculate the entropy of the inputs, right?
Inputs we can do. We will do it later, but let's just do it on the this one only right now. Malignant. So in the one of the next question, I will also do with respect to the vaccination. Okay, but for now, let's check how to do it on this one. Only just this row, this, yeah, this column. So basically, here, if you just apply this formula, then you will get the answer. So I is actually the classes. So 0 is one class here and 1 is another class here, and P of I means like what is the probability of that class appearing here. So if you just consider this column, what is the chances of if you pick one of them randomly, what is the chances of what is the probability of getting 0?
By 12.
Yes. What by 12? Can you repeat?
Probability of getting 0, 7 by 12.
Yeah, and probability of getting 5, probability of getting 1 is 5 by 12.
5 by 12.
Right. So what you have to do is that you just have to put these values. Okay. So one is for 7 by 12. So this is for class 0, and another is for 1, which will be 5 by 12. So this will be the formula. At first you put the minus, then 5 by 12 log 2, and then again 5 by 12, minus again 7 by 12 log base 2, 7 by 12. So if you calculate these values and then if you add them, because like both are negative sign, right? So you will get 0.9798. So this is the entropy of the malignant column. So is the calculation clear to everyone?
Yeah.
Okay. So this is the next question. So this is about the another column. So
Sir, how to calculate log 2?
okay, how to calculate log 2?
Yes.
So log 2 means like you have home, like 2 to the power what equal to this value, 2 to the power what value is this. So basically you can like use calculator for this calculation.
By computer calculator, can you show?
Okay. So in the computer also, like you have to use kind of scientific one. So just go to here. Is my screen visible to everyone? Like calculator visible?
Calculator is not visible, screen visible.
Okay, okay. Let me reshare the screen. So basically, I am using Ubuntu. If you are using Windows also, I guess there is a computer. Okay, so let me just show from the beginning. So just go to start, type the calculator here. Okay, calculator will appear. So basically, generally you have the basic, okay, this thing, but to calculate log and those things you have to go to advanced. Okay, advanced we have that. So log base 2, so you have to find base 2 actually. Okay, let me just search it. Generally, like we just use Google, but in some cases you may not have access to Google. But in the Google, you can just like you can just like type that.
For exam, we have to use the computer calculator. No,
Yes,
that's
yes,
why I asked.
yeah. That's why I understand. But yeah, I'll show.
Suppose you have to find the log 5 by 12 to the base 2, you just do log 5 by 12 divided by log 2.
Mhm. So what is what are you saying?
I am telling in a calculator, in a scientific calculator, if you have to find, say, log of x to the base 2, then you just do log x divided by log 2.
Yeah, yeah, that you can do. But in yeah, and that is one way. Another way is that you can in most of the calculators there should be an option to find to define the base actually. So here 2 is the base, so you should have the option to define it here. But yeah, in that case also, let's say we have this question, right? 5 by 12 log base 2 and 5 by 12, so you can do this like log of 5 by 12 and then you can divide it by log of 2. So this is the answer. Okay. And just let's check it once.
So when you do minus 5 by 12 into what you got, no, now the answer you got is negative, isn't it? So when you do minus 5 by 12 into that negative, you get a positive.
Yes, yes.
And that is something greater than 1. And then again, the next thing is also similarly positive. So you're basically adding two positive numbers greater than 1. Then your answer should be 2 point something, no? But your
No, no.
final answer is something else.
Yeah, I'll show you it. I'll show it. So actually we are multiplying it with something. So I'll show. But here you can see if we just calculate directly and if we calculate by this, it is just the same. Okay. So here I am showing you. So basically we are getting value more than 1, right? But we are multiplying it with this 5 by 12. So it will ultimately come to come below 0, come below 1. So in this case I'll just show you. So this is the log 2 into 5 by 2, okay, into minus 1 into we have to multiply by 5 by 12, right? So this is 0.5262, right? Plus let's find this one also, log 2 of 7 by 12, right? So this is the answer. Again you multiply by minus 1, you multiply by 7 by 12. So this is 0.4536. So if you add this with this value, you should get less than let me just paste here. So it will be like less than, definitely less than, it should be less than 1, because we are like multiplying with a value which is less than 1. Both 5 and 7 and 5 by 12 and 9 by 12, 7 by 12 both are below 1. So yeah. So 9798, this is the value, 9798. Okay. So again, if you have 3 class problem like 0, 1 and 2, you have to just add another variable. Suppose you have 15 thing like malignant, yes, no, and suppose there is another thing called unsure, not sure if it is dangerous or not, suppose that is labeled as 2. So you have to suppose there are 3 in number, so you just this equation minus again 3 by not this equation, because total is 15, right? In this case, suppose there are 3 additional 3 additional data, so it will be 5 by 15, 5 by 15, 7 by 15, 7 by 15 minus 3 by 15 log base 3 by 15, like that. Like whatever the classes are, you have to perform via this equation. Okay. So is the calculation clear to everyone?
Yes, sir.
So then I'll go to the next question. So in this case, whatever we have done is that we have calculated with respect to this output only, and the not output, the reference, like I mean the label, right? So the next question is how to find information gain. So suppose we have this column vaccination, okay, and then we have this alignment, this is a level. So if we have the vaccination, what is the information gain here by this column? So we have to find it via calculation of entropy with respect to vaccination also. Entropy of vaccination with respect to this level. So by that we can find the information gain. So just write here once. And this is also, I think, yeah, and this is also have been covered in the lecture. So again, for vaccination also you have to find, you have to kind of partition them, the vaccination column with respect to this. So anybody having any idea to how to solve it?
So you have to take the entropy of vaccination column with respect to the output malignant.
Yes.
So okay, so the wherever vaccination is 1, all the malignants are 0, and when the vaccination is 0, that we have to split into 2 again, because
Yeah.
in some cases.
Okay, slowly let me go to the solution now. So at first what will happen is that we are trying to calculate the entropy with respect to the vaccination. So since this is kind of let's say not the label, this is one of the feature. So in this case, what do we need to do is that we need to divide the data set. Divide the data set means we will consider when let's say whenever we are having 1 in the vaccination, we will consider them differently. Whenever we are having 0, we will consider them differently. Suppose you are taking this, in this case suppose you are considering entropy with respect to tumor size, then we will consider small separately, medium separately, and large separately. So basically here we are taking 2 1 3 1 4 1 5 1 5 1, okay, and we will just check these rows, okay, only these rows. So how many of them are 0? None of them are 0, right? So it is 0 by 5 log of 0 by 5 minus how many of them are 1? All of them are 1, right? 5 by 5 into log 2 5 by 5, right? So if you take the calculation log,
Can you please this?
yeah, can you repeat?
Can you please repeat how you got 0 by 5 and 5 by 5?
Okay, so I am trying to calculate here. So in this case, okay, we have vaccination equal to 1, so we are just considering the vaccination values here, okay. So 0 means how many of them are actually getting 1 output here. Whenever we are having 1 here, how many of them are having output 1 here? None of them, right? 0 by 5, 0 by 5. And how many of them are having output of 0 whenever we are having 1 here? So that is 5 by 5, right? So whenever we are having 1, in all the cases we are having 0 here. So is it clear? So if
Yes.
you, yeah. So you have to check whenever there is 1 here, and what is the corresponding output, what is the corresponding level. So you have to consider for one level once and another level once. So for level 1 we don't have anything, 0 by 5 and 0 by 5, and for level 0 we have 5 of them out of 5. So 5 by 5 log to 5 by 5. So if you calculate, 0 by 5 is definitely 0. So this is 0, and 5 by log of 1, log base of 2 of 1, or log base of whatever, if we have 1, it is 0. So both of them are 0. So this actually is 0. The entropy when vaccination equal to 1. So that value is 0.
Sir, please explain once again. How did you get 5 out of 5?
Okay. So,
I understood the first part, 0 out of 5. Please explain the second part.
okay. So let me write it. Okay, here. And just let me move the equations a little bit. Okay. So zero by 5. This is number of labels equal to 0 equal to 1 when so this number is what? This number is 5, and number of labels equal to 0 when vaccination equal to 1. This is 0. No, it is opposite actually, right? So basically suppose we have just for a moment forget all the zeros here, only let's consider the 2, 3 and 4, 5 rows. Okay. So in the 5 rows, just look at the output, how many of them are 1. So it is 0, it is 0, it is 0, it is 0, it is 0. So none of them are 1. So we have 5 options, 5 rows, and out of them none of them are 1. So this is 0 by 5. Also this is like just using this equation, this is 0 by 5. Then this is happening for 0, this is happening for when level is 1. Let's find out how many of them are 1, how many of them are 0 when vaccination equal to 1. So here vaccination is 1, so 1 match, 1 0, so 2, 1 0, 3, here also 1 0, so 4, 1 0, here also 5. So 5 of them are having 0 level out of total 5 examples. So this is 5 by 5 log base 2, then here also 5 by 5. So is it clear how is it coming?
Sir, but here we are calculating only when the vaccination is equal to 1. But why are we not calculating when vaccination is equal to 0?
Yeah, we will also have to calculate that. I'll come to that step.
Okay.
Yeah. So for everything we need to calculate, then we have to kind of find the not average, weighted average. Weighted average means how many proportion of 1 and 0 is there. Based on that we have to calculate. So I have done it for 1. So
Is
can
the
you
final answer 0.8?
which one?
Hello. Is the final answer 0.86312?
861 for like information gain.
No, this entropy, like entropy of vaccination equal to 0 plus vaccination equal to 1.
No.
Because
So
for vaccination is equal to 1, it is 0, no? Entropy is 0.
yeah. So for can you just find for vaccination equal to 0? What should be?
That's what I found it as 0.86312. I want to know that.
Okay, that might be correct. I'll check it in a minute. Let others also try it. That might be correct. Yeah. So just try it for vaccination equal to 0.
In the last lecture, like in this week's last lecture, here there is one example taken for the decision tree. So in that example, he also multiplied weight in this.
Yeah.
So we have to multiply weight in case of
Yes.
this case.
We have to basically. I'm just trying to show it by step for simplicity, but you have to multiply it. Yeah.
Okay, fine. My final answer is coming like 0.5.
The information gain, right?
Huh?
Information gain.
The entropy for the vaccination.
Yeah, it is near to that.
So if there is no split between classes, that is if all the values belong to one class, the entropy is 0. But if there is a 50-50 split between the classes, is the entropy 0.5?
No, it is not 0.5 actually. So just consider it here. So if even though it is kind of a question in the assignment, okay, but just in case of just apply this formula, 50-50 means 1 by 2, 50-50 means half, right? 1 by 2 log base 2 1 by 2, here also 1 by 2 log base 2 1 by 2, whatever the answer is, that is the answer. So 50 means both the classes having half of the examples.
Yeah, got it. Thank you. can we work out some? Will in the session will we be working out some examples of greedy approach for decision trees and reduced error pruning? Because that's not quite clear, but there are questions.
So yeah,
Concept is
like
not
I haven't really prepared examples for that topic, but
just look at the assignment questions and give us hints on how to
yeah,
solve it.
yeah, I have generally focused on the mainly previous year assignments actually. So, but I think there is a last lecture in that session in this week. So, is it clear from that? Is it still not clear from for you?
Oh, the last lecture just focused on this entropy, what you're doing now.
Yeah, yeah.
But other than that, the greedy approach for creating decision trees and reduced error pruning, the concepts are not very clear. So therefore, I don't have the knowledge to solve the questions asked in the assignment based on those concepts. Reduced tree pruning and greedy approach.
Mm-hmm. Yeah, so in that case, like you can follow that book, Pattern Recognition and ML, so which is kind of the suggested reading material for this course. So, if you want to get a detailed picture of what is happening. Okay, then I will be moving on to the entropy when vaccination equal to 0. So, again we have the same formula and we have to find whenever we are having vaccination equal to 0, how many of the labels are 0. So, we have 7 zeros here, okay, and we have only 2 of them are 0, right. So, this is one class 2 by 7 log base 2 and 2 by 7 minus in case of 5 examples 5 rows we have 1. So, again we have to calculate this 5 by 7 log base 2 5 by 7, okay. So, if we calculate this log base 2 of 2 by 7, it is this one, log base 2 5 by 7, this is this one, and like minus minus will get plus, and this is also will get plus. So, if we just add them, it will be like this 863120. So, basically it is just the same as when vaccination equal to 1. So, this is actually we have done entropy without any weightage or anything, okay. So, but you know there are 5 ones and 7 zeros. So, whenever we are calculating entropy, we have to calculate with respect to that, okay. So, total entropy of the feature vaccination is that 5 by 12 into 0. 0 is because you know 5 is the number of 1 here, and what is the entropy when vaccination equal to 1? The entropy is 0 plus 7 by 12. 7 is the number of 0 level here, 0 here, and 12 is the total, and this is the entropy when the level is the vaccination value is 0, okay. So, if we take the average, so this is 0 and 7 by 12 into this, and the value will come out to be 5034, okay. So, this is not the the final question was that you have to find the information gain. How to find that? You just calculate the entropy. So, entropy of the whole data set, this is like this, entropy of this minus entropy of the vaccination, and if you subtract that you will get this value, and this is the information gain. So, this is the answer here. If you have any doubts in the solution, you can ask.
How you got 0.9798, sir?
Okay, so 0.9798 we got from here, this. So, this is the entropy of the label melanin.
Okay, got it.
Can you, sir? Yeah, no. Can you just next slide?
Yeah.
No, ah, yeah, this one.
This one?
No.
Yeah.
Where you got the final answer, no?
Yeah.
The next one, next one is.
Yeah.
Here. 5 by 12 into 0 plus 7 by 12 into. Oh, okay,
Yeah.
okay.
So 0 is for here when vaccination equal to 1, and this one is for when vaccination equal to 0, and we are just taking the weighted average. Okay, so
Sir, how did you calculate vaccination equal to 0?
okay, vaccination equal to 0, you can see here. So we are just taking the we are just looking at the rows where vaccination equal to 0, this row, and last 5 row. Then we have to find
0.86, right?
yeah.
Okay.
So this is without weighting with number of levels, so ultimately we have to weight it. 5 is the number of zeros here, 5 is the number of 1 here, and 7 is the number of zeros. So you have to take the weighted average of that.
Thanks.
So for this type of question, you have to calculate the first Magnilent classes also, the entropy of Magnilent also you have to find out first.
Yes, so I have done that in the previous question, right?
So it will be very lengthy then one.
Yeah, in the exams it will be like examples will not be, I guess, not that long one, but yeah, you may have to calculate it. Like I don't even know if this question will come. This may or may not come. Okay, but you should know that. So suppose there are, instead of say 12 examples, suppose there are maybe 4 or 5 examples, 4 or 5 rows. Then like you should be able to do it, right?
Sir, can you explain information gain?
Yeah, so information gain here is the this is basically calculated as the entropy of the label here minus entropy of vaccination, this one. So basically by that we mean that how much information we are getting by using this vaccination column. So this was the entropy earlier, 0.9798, okay, and with vaccination information entropy is this, okay. So entropy is much lower than the earlier, so that entropy we have gained, right? Like that entropy we are able to reduce. So this amount of entropy we are able to actually this amount of entropy we are able to reduce, okay. So this is actually we are calling information, that is the how much the column vaccination is contributing to the variable here.
Okay, sir.
So I'll go to the next question. Which of the following machine learning models can solve XOR problem without any transformation on the input space? So we discussed it earlier that some of the XOR is actually not a linear model, right? So you cannot draw a line to separate the XOR graph drawn by XOR, right? So which one among the following can classify them? So suppose we are giving input 0 0, it should give 0 0 1, output should be 1 1 0, output should be 1, and 1 0, output should be 0. So which of the following model can do this?
Is the answer decision trees?
Yeah, and one of them, is there any other that can do? It may, others may or may not do. I'm just asking, do you think any of the other 3 can do?
Neural network? No, but logistic regression, I'm not sure.
Yeah. Is there any answer in the chat? Yeah. Okay, there are some answer earlier also. Yeah, there are some scientific calculators. Yeah, actually, this is very important. So Prashant has shared this link. Okay. So in the TCS, you will get this kind of calculator, like in the exams. Okay. So you can just use this one for calculation, log base 2. So answer is C, but multiple might be correct. So is the still answer C? These are the options. So linear perceptron we discussed earlier. This is just the boundary must be linear. It cannot separate non-linear things. So linear perceptron cannot do any without any transformation or anything. It cannot classify ZOR. Neural network, it can suppose a neural network means it has multiple layers of perceptron, not one. Okay. So in that case, suppose in one layer we are dividing that maybe in one layer we are deciding that maybe 0 0 is 0, and in another layer maybe we are deciding 1 1 is 0, in another layer it is like 0 1 is 0, or anything like it is kind of like multiple linear perceptron. So what will happen is that in case of a neural network with more than like if in like perceptron we don't have any hidden layer, but in neural network we have some hidden layer, and if we have hidden layer it can solve the ZOR problem, because it can divide the problem ZOR problem into multiple parts, and each of them will be linear. Okay. So suppose let me just draw a diagram. So suppose I have drawn this diagram earlier also. Suppose this is the x1, this one is the x2, this is 0 for both, this is 1, and suppose we are classifying 0 as a triangle suppose, and 1 as a square suppose. So in case of 0, x1 is 0, y1 is x2 is 0, so output will be 0 ZOR, right? And for 0 1 it will be 1, suppose square. 0 1 here also it will be 1, but here it will be 0. So we cannot draw a line such that these two are these two are classes are separate, but when we are having neural network we can do what? We can divide a line like that, we can divide another line at that. So this is suppose one hidden layer, this is the one layer. So by this way we can separate, because in the linear perceptron we have one line only. So but in case of neural network we have multiple hidden layers, and in each of the layer we can draw something like this. So we can separate it kind of here. Okay. then next one is decision tree. So decision tree, we told earlier that a decision tree we can do. A decision tree we can map any complex function. We can, because there are multiple levels of things, so we can do nonlinear decision things in the decision trees. Logistic regression also works at just like linear perceptron. Okay, so what if we are unable to do it at linear perceptron on the like separation, we will not be able to do it as with the linear regression, because both the cases it actually works on same principle, and it actually assumes that we have linear decision boundary, but that is not the case in case of SAW. So logistic regression is not a correct option. Then we have two statements. So decision tree is an unsupervised learning algorithm. Is it correct? And then we have another, is we have a supporting statement that splitting.
So what was the answer for the previous question?
Yeah.
Neural decision trees and neural networks. Okay.
Yeah.
Yeah. Thank you.
So in this case, reason is the splitting criteria use only the feature of the data to calculate respective measures. So basically what we are saying is that in the decision tree we are using splitting criteria, and in the splitting criteria we only use features of the data to calculate the respective measures, like which class is which. So we don't use any labels in decision tree for training. So that is why it is called unsupervised. So that is the statement and that is the reason. So are they correct? Is only one of them are correct? What is it? Okay, the answer is this. C is what? Statement is false, reason is true. So any more answers? I'll just wait a minute. Okay, another answer is D. Again,
can you show on your screen what is the
yeah.
question? Thank you.
So the simple question is, can we build decision tree if we don't have the labels?
No, you can't. You need labels. Decision tree is a supervised learning algorithm.
Yes. So basically, just let me show you a decision tree, and so basically in decision tree at the leaf nodes, we take the decision if some conditions are satisfying, and then we decide that what is the level. But if we don't have level, we cannot really get anything actually. So yeah. Okay, so let's say here yeah, so you have a kind of instance kind of thing, and you have to decide that if the like whatever the person, your customer, if he or she is high risk or low risk. Okay, so basically we are taking the age if it is greater than 30, and if the person is smoking, that it is high risk. Otherwise, say if it is between 18 to 30, no matter what or he or she does, it is kind of low risk, this kind of thing. So in all the cases, we are considering that this is the level: low risk, high risk, low risk, this kind of thing. But if we don't have these levels, so how will we split this? So we cannot really split this, right? So basically we are splitting based on this, right? No or yes. Suppose we don't even know what does no, like we don't have these levels: low risk, high risk. So we won't even know that if the person is non-smoker, so what kind of risk will be. So in this case, we do need the labels to make decisions, to like construct the decision tree at all. So this cannot be done without labels, and if we are using labels, that means that is a supervised learning algorithm. So obviously the first one is false, because this one is like supervised, because we are using labels, and reason is also false, because in this case we are actually using the labels to as a like splitting criteria, because without labels we will be clueless which criteria to use to perform the splitting. Okay, so we use both the features as well as label to split those. So this is the next question. It is kind of fill in a blank. So this is a
Sir, can you go back to the previous question?
Yeah.
Okay, thank you.
So you have a fill in the blank type question. This is a measurement of
Previous reason is true, no, but only the statement is false. Previous
no,
statement
reason is also not true, because splitting criteria, we cannot decide that based on, if we don't have the label, we cannot really perform the splitting, right?
yeah.
So yeah, you can split, of course. Say suppose if it is greater than 30, this side, less than 30 that side, but what does they mean? It will be like we are splitting without any reason. So ultimately, if we go down, if you reach a lift node, we will not get any level that if it is high risk or low risk. So the splitting kind of becomes pointless. So in that case, suppose we don't have any labels, we can say that greater than 30 is this side, or more than 25 is that side. We cannot even decide which value to choose to split that without labels.
Yes.
So that is why it is false.
Sir, one thing I ask you that is the reason is given for the statement logical value, no? To prove the statement logic, it is correct or not. So if the statement is false, the reason obviously it will be false. No?
Yeah.
Is it any case should be
Sorry,
can it be happen? Because reason is for that validation of the statement. So if the statement is false, the reason obviously it will be false. But if the statement is true, the reason may be false or true.
yeah, that is correct.
Correct.
Yeah.
That means if statement is false, that no need to see reason also, but reason will also be false.
Yeah.
Can you conclude like this?
Yeah, it is right, but in certain cases, so suppose let's take an example.
In any case, the statement is false, reason is true.
Suppose let's say okay, so suppose just take this example only, and suppose in the reason we have the splitting criteria use only the use both features and labels to calculate the data. Okay, suppose this is the reason, right? So instead of features we are saying features and labels. So in that case that reason will be right, but that reason, even though it is right, is not concluding that statement is correct.
But this reason is not the validation for the statement.
Yes, yes. So that kind of
So
thing can happen, right?
so that may not be the reason. You cannot write that reason. The splitting criteria use both levels and features for the unsupervised learning. So you cannot write this reason for that.
Yeah.
If you write the statement is decision trees and unsupervised learning.
Mhm.
So reason is the validation for the unsupervised learning. Why they are saying unsupervised learning? That's why they're giving this reason.
Hmm. Yeah, yeah, you're right. So in case of the reason is not contributing to whatever statement is saying, even in that case the reason should be like not a correct reason. So even in that case it would be false. So yeah, if the statement is false, then reason would be false. Yeah. So moving on to the next question, we have 4 options and we have to find the likelihood of incorrect classification of a random variable and which could be the option. So Gini impurity, entropy, information gain, and none of them.
Gini impurity.
So yeah, this is discussed in the lectures. So basically, obviously, entropy is not that. Entropy is like we calculating on the whole data set thing. So it is not really dealing with the incorrect classification entropy. This is about like among the variables. Information gain is also about that. So only correct option here is Gini impurity. Then what is the common indicator of overfitting in a decision tree? So what can be the symptoms? So first one is that training accuracy is high, validation accuracy is low, tree is shallow, and third option is tree has only few leaf node in the like whenever we are making the final decision. We have very few number of those, and then the tree's depth matches the number of attributes, like number of variables in the training data, and last one is that predictions are consistently biased. So which one only just if I ask you to pick only one, which one would be?
A.
Yeah. So basically not only in decision tree, so no, this is not Gini entropy question. Yeah, in the previous question it was the answer was Gini impurity. So in this question and anywhere whenever you are seeing that overfitting, the symptom will always be that accuracy will be high during training and validation accuracy will be low, or vice versa. If you consider loss, loss will be low during training and high during validation or testing. So this is the solution. Training accuracy is high and validation accuracy is low. So
You just showed the Gini index question, just the wording of that question.
yeah.
If new instance is randomly classified as per the distribution of class labels from the data set. Okay. You can move on. Thank you.
So which of the following is a common method for splitting nodes in a decision tree? So whenever we are splitting the nodes, whenever we are deciding that to create branches, based on which we'll decide.
Cross validation?
No. So cross validation, we don't really use cross validation to perform, say, splitting the nodes. After suppose training a decision tree, we can decide that with cross validation we can kind of see how it is doing based on multiple folds. Okay, but the splitting itself, where we are deciding that which path, where to create branch or no, that we don't really do with cross validation. So gradient descent is also not used here. Principal component analysis is also not used here. So only correct answer is Gini impurity. So what will happen is that we'll calculate the Gini impurity, and wherever we are seeing that if we split at this point and if we create these two branches, then this will have the maximum impact on the classification. So basically, suppose you have a multiple variables, suppose, and a label, and at some point you have Gini impurity of something like let's say you have a Gini impurity of some value of something, and then what we do is that if like Gini impurity means that we have a high number of misclassification there, right? So from that point we split again such that we can again make it into multiple classes, right? So suppose at some point we are giving everything as suppose true, but we are getting high number of misclassification there. So in that case, we will again split again, and we'll set another criteria to divide them between true and false, so that misclassification can be reduced. So
Can you show the last question answer?
this one.
Previous, this one. Repetition. Okay, move on.
So what is the advantages of using decision tree? So sorry, what is the disadvantage? Option A, it is very it has very high chances of overfitting. Then second option is that it cannot handle categorical variable. Third option is that it cannot do nonlinear relationship, and fourth option is that it is very hard to calculate. I mean, if we are classifying something, it will take much time to train, and also it will take much time to test the model. So which one is the disadvantage?
Computationally expensive?
Okay, so decision trees are not really that much computation expensive, because yeah, if the number of input variables, a number of features is too large, then it can go very it can become a very long tree. But generally, if you consider, it is not really the case. So if you compare with neural network, suppose neural network is even more computationally expensive, but generally in decision tree, yeah, it can become computationally expensive, but this is not really the main disadvantage. Another option is that they cannot model nonlinear relationship. So this is again is not true. So they can handle nonlinear relationship, because in perceptron we cannot do nonlinear thing, but in the decision tree we have multiple decision points, and we can map a complex function with that. So this statement is false, not correct at all. This is kind of correct, but again not that much expensive. And another thing is that they cannot handle categorical variables. That is also not true, because if we have categorical variables, we can perform one hot encoding, right? So suppose we have blue, green, yellow, we can convert it to like we can keep one column for blue. So whenever the label is blue, we will give one there, and one category for green. Whenever the label is green, we will keep one there, and empty words it will be 0. So by that we can easily handle categorical variables with one hot encoding. So this is again is not a challenge. The major disadvantage is overfitting, because you don't know, you have a suppose data and you don't know how much long the tree should be. So if the tree is much complex, so in that case there is chances of overfitting, and it is and you cannot just make it arbitrarily small. In that case it will kind of underfit. So it is kind of very hard to set an optimal situation where you are getting optimal results. So in most of the cases, what happens is that you have multiple features in the input, and it kind of learns the decision that if it is suppose greater than 35, it will be like if the weather is suppose it is greater than if the weather is less than 20, it will rain. This kind of thing will be there. So just based on the few input examples. Okay, so even though there are some outliers, it will try to map it into that pattern. So this is what we call overfitting. So this is one of the major disadvantages of decision trees. So next question, what is the purpose of pruning in decision trees? So there can be many solutions here again. So what is the most important thing here? First one is to optimize the tree parameters. Second one is to handle the missing data. Third one, to reduce the drift and prevent overfitting. And last one, to make the model more interpretable in the sense greater than this, we can say because of that we are saying it is true. Less than this, we are saying because of that it is false, like that.
C, option C, to reduce the depth of the tree and prevent overfitting.
Yeah, right. So basically the major objective here is that we should all are correct. So a major objective here is that if the tree grows to be very much complex, it will also fit to the outliers, which it should not. So in that case we actually prune some part of the tree such that overfitting is minimized. And also, like if we reduce the depth of the tree, it will also be kind of so if we reduce the depth of the tree, then it will also become computationally less expensive. So you can come to a decision earlier compared to if you have the full tree. So main reason is the prevent overfitting, and this is also another reason. Okay, so this is the last question, I guess. Which of the following is not a common use for decision trees? So we have like 4 situations, and
Image recognition is not a common.
which one?
Image recognition is not a common.
Okay, can you explain why?
Because the image recognition has lot of parameters, no? Like there will be like pixels will be in the order of 10,000 or millions.
Exactly, yeah, you're absolutely right. So in all the cases, medical diagnosis, suppose you have a kind of Excel kind of thing, and you have multiple features, so you can send them via you can use the decision trees at multiple points, and you can decide that if the person is healthy, unhealthy, if he is having this disease or not. Credit risk assignment, again you have multiple attributes and you have to decide if he will be able to repay the loan or not, kind of thing. Customer segmentation, you have multiple features and you decide that if you are suppose you are dividing them based on the income or based on say age, based on how much their property is, this kind of thing. But so all of them has kind of limited number of features. But in case of image recognition, so suppose you have a, let's say a picture, even the let's say even suppose you have a very small size picture, let's say 256 into 256 pixel. So 256 into 256 is a huge number, right? So you cannot really apply decision tree here because the number of features are way too large, and you cannot way too much decision point to be computationally feasible for that kind of decision. So image recognition is the correct answer because it is decision trees are not really much effective at handling high dimensional data. So image recognition is having very high dimension of the data. So this is the correct answer. Okay, so another question, you have a decision tree, you have the root node, you have the intermediate node, and you have the leaf node. So what do we do at the leaf node? So at the last, suppose we have a decision tree at the end, at the leaf node, at the last node of some path, what we do?
To represent the class label or value to be predicted.
Yes. So basically, what happens is that in the last node of a path, what we call a leaf node, in that case, we are able to reach a decision that if it is this class or that. So in that case, there are no further division, and we can say that this example is belonging to this class. So first one is the correct answer. Okay, so these are the questions that we will discuss for this time. Then there is another, if you want to learn also the practical thing about this decision trees. So there is a Colab notebook by Shubhadeep Hajra. So this one you can check it out on the Google Colab. Okay, so this is I will share the link of the slide, and in the slide you can find the link. So in this case, I'm just opening this. So it you can load the data set, you can perform the linear decision tree. So in this example, specific example, what we are doing is that we are just at first importing the libraries. We are using sklearn and we are using matplotlib to plot those. We are getting iris dataset. Iris is basically an image dataset. Okay, so we have a sepal length, sepal width, and petal length, petal width. So these four are the features, and based on that we have to find that if the if the flower is this one, or this one. Okay, so just loaded the data, and we are basically using the decision tree classifier module from the sklearn, and we are using criteria as a Gini as the criteria, and we are performing base split, and we have some kind of a some parameters that we are passing, and then we are providing the training data and training levels. So these are the features and these are the levels. Okay, and we are fitting that model on this. Okay, and then we are then predicting that after training is done, so here training is done, so after that we are fitting it to a like we are predicting that what is the labels of the first 5 examples. So first one is that it is this one Virginica. Second one is that versicolor, and third one is Setosa, and then again Virginia. Okay, versicolor. So this is the like the prediction. Then you can also visualize the tree here. So this is from a sklearn tree. So you have a classifier, okay, and you have the you are passing the classifier, so the trained model here, okay, to this module plot tree, okay, and you can get this kind of diagram, okay. So yeah, this is not properly visible here, so you can also do this. So suppose you have trained the model, okay, and you are getting a decision tree. So we are saying that decision tree is interpretable, but how exactly to visualize if it is interpretable? So this is the condition here. So if the petal length is less than 2.35, so is it true? So if it is true, then it is going here. If it is false, it is going here. Okay. So if it is true, there are no more branches. If it is false, then we are seeing that if the petal width is less than this, okay. If it is less than this, then we are coming here. If it is greater than this, then we are coming here, okay. Then again, if petal length is less than this, we are coming here. Again, if petal width less than this, we are coming here, and at this point we have reached a decision that this is the say, if it is less than this, it is versicolor. If it is not less than this, so it is greater than 1.65, it is Virginica. Here also, if it is if the condition is no, then it is here, this condition, like this. So you can visualize the images, the decision tree, whatever, like the model has the sklearn, using sklearn we have trained. You can visualize the decision points here, okay. So if you use that model, so this is what we are planning to cover in the session. So again, if you check this also, so these are the kind of decision boundaries, okay. So if some point is within this part, then it is say red. If some point is coming at here, it is kind of yellow, okay. If it is blue, then like this, okay. So there can be like multiple decision points. Suppose here there is one blue here another part of blue, here also another part of blue. So same here, right? So here we are getting, if it coming via this, it is versicolor. But again, if this condition is not satisfied, okay, if this is not true, then also via some other way we can become this, okay, versicolor. Same for like Virginia, there are multiple like root nodes which are given Virginica, okay. So this is the visualization, okay. So I have given the links here, links on the slides, and I'll you can see the slides in the spreadsheet that has been shared with you. So if you have any more questions on this regarding the whole session, you can ask me. Kindly take one example for reducing error pruning. Okay, I'll list such an example on internet and I'll explain. Okay, so suppose okay, I'll try to go it in detail at some point, but suppose just consider this, that in this case what is happening is that we have initially we have this tree. Okay, so if the income is greater than 30,000, we are checking if the person is having loan from the same bank. Okay, if it is yes, then we are giving the loan. So that means that he already has a loan, so he can he's aware that what the loan is and how to be serious about loans, and he can repay back the loan. Okay, so that means like that person has already has a loan, and he is trustworthy because we have already given loan once, so you can trust him. So this is yes. If it is no, then do we need does the person have documents? If it is yes, then fine. Okay, then we are giving loan, otherwise no. So this is fine, this is correct. But suppose in the right hand side of the tree, if the income is less than 30,000, we are checking if the person is having criminal record. Okay, if yes, we are not giving loan. If no, if we are having say document, if the person is not having document, we are not giving loan, and if the person is having a document, we are giving the loan. So the thing is that suppose there are multiple errors occurring here. Okay, at this point. Okay, so instead of doing that, we just prune that, we just remove this, all this, and we just keep that if it is less than 30,000 income, we will not give the person loan. Doesn't matter if he or she has criminal record, or doesn't matter if he or she is having a record document. So I will try to give a detailed example. I will just try to search something. So check another simpler example actually. Okay, just let's go back to the previous example and explain it there only. Okay, so so basically what will you do here is that suppose we'll check from the leaf nodes. Okay, from here, and let's check if we remove these two nodes and just keep it here. Suppose there are 5 nodes and say 3 yes here. Okay, instead of if we just remove these two part and just keep it as like suppose there are 5 no, so majority is no, so instead of giving another leaf node, another branch, we are just keeping it as a no, majority, right? So will it increase the error? If it is increasing, then we will not prune it. but if it is decreasing the error or keeping it same, then we'll just remove this and post the no here. For example, here you see, suppose we are seeing that suppose here there are 10 no and 5 yes, okay, and then majority of them are no, right? So instead of here, instead of creating another bunch, if the criminal record is no, we are saying that no loan, okay, here no loan, yes, no loan, okay. So in both the cases we have no loan, okay, no and yes. So again we are going one level up here, okay, and we are saying that if we have if we just merge them, like okay, let's for example, let's just take here yes is more, okay, yes is suppose 10 and no is 5, okay, and here we are thinking that suppose if we remove this and just say if the criminal record is no, we are just giving the loan. Here we are saying yes here, okay. So will it reduce the loss? Will the loss remain the same? Okay. So if the loss will get higher, if the loss is not getting higher, then we'll say that what is the point of like this kind of decision if we can decide at this level, right? So we'll just remove this. So we have kind of here with no we have loan, with yes we have no loan. Again we'll check at one level up, and here we will see that suppose here we have like 5 like total here suppose 10 plus 5, so 15 we have done here that no, okay, but suppose there are yes 25 times, okay. So again we will assign a majority here. So if the income is less than 30, let's assign the majority yes, okay. I am assigning the majority yes here. So yes means here like no loan, okay. So if the no loan, we will again check the if the if we do this, if we assign, if we remove, if we prune this and just keep the maximum here as a leaf node, will it result in bad loss? Will the loss be affected? If the loss is not negatively affected, then we can just prune the tree. So by this way we prune the tree based on the loss function. So I hope it is clear. Okay, like if you don't have any questions, then I can end the meeting. But yeah, like if you are having any difficulties in following through the lectures, yeah, at first the first thing is that your linear algebra and probability background should be clear, so you can find those week 0 lectures. But again, for details you can follow books on linear algebra and probability, books or lectures. So for linear algebra we have lectures from Gilbert Strand, who is a very popular mathematician, so you can follow that. And another one is that like for like other stuff, like from week 1 to week 6, whatever we have followed, you can obviously like try to find other sources, but the main course content in the course is followed from that book. So this one, pattern recognition and machine learning by Bishop, which is like available online freely. So this is like a very popular book, very known book by Christopher Bishop. So this, the first link is available. This was from the hosted at Microsoft. So you can just go to this link, and yeah, this is the link, and you can search the topic and you can learn it from here. because like small doubts I can obviously clear, but if you are talking about bigger topics, it is not possible to solve in the problem solving session because of time limitation and stuff. Okay, so you can follow this book. So this book actually contains most of the things that is covered in the lectures. So this is much more detailed. So you can follow this book for to understand if you are having any doubts. Okay.
Sir, one query. In case of a decision tree, the variance and the bias which will be there, that depends upon the problems, right, sir? What kind of a problem we will get?
Yes.
Or in general, we can define?
No, actually, so that will depend upon the problem.
Okay.
Yeah. Yeah. Okay, then I am ending the meeting. Thank you very much for joining, and you have assignment deadline soon, so solve the assignment and submit. So I hope this kind of I have seen the assignment questions, so those are not really exactly very similar, but numerical things. I think if you have understood whatever I have covered in the session, you will be able to solve those questions. Okay. So thank you again for joining. Good day.
Thank you, sir.
Yeah. Thank you.
Thank you, sir.